So, your IGCSE Physics Paper 4 exam is coming up, right? And we all know it's a big deal. It's a huge chunk of your final grade. So today, we're going to skip the content review and get straight into strategy. This is your guide to not just passing, but absolutely conquering this paper. Let's get right into it. So what's the secret sauce? What's the key to really acing paper 4? You've done the studying, you know the formulas, but this paper can still feel like a massive challenge. What's the one thing that separates the good scores from the truly great ones? Well, here's the thing. It's not just about knowing your physics. It's about knowing how to decode what the examiner actually wants from you. Think of it like a game, and today, we're going to learn the rules. Success comes from understanding those little command words that tell you exactly how to frame your answer. All right, first up, and this is probably the most important part, we need to talk about these command words. Seriously, think of them as direct instructions from the examiner. If you follow them, you are setting yourself up for maximum marks. Let's start with the most straightforward one. Okay, so if you see the word state, think short and sweet. They just want the answer. That's it. No need for because or any long story. For example, if it asks you to state the name given to negative acceleration, you just write deceleration. One word, one mark, done. Next up is describe. Now for this one, I want you to imagine you're a witness to a scene. Your job is just to report what you see, the what, not the why. So if you're describing solids versus gases, you'd say that solid particles are in a fixed pattern, just vibrating, while gas particles are really far apart and moving around randomly. You're just painting the picture. Now, define is a whole different ballgame. This is where you have to be super precise. You need to give the one single official textbook definition. There's only one right answer here. So if the question is define pressure, the answer has to be force per unit area. Sure, P equals rho GH is a pressure formula, but it's not the definition. You have to give them that core concept. Okay, let's step it up a notch and tackle a compare question. This is where you look at two things and talk about how they're related. What's similar, what's different. Let's use a great example. Comparing the wavelength of a sound wave in air versus that same sound wave in water. And to nail this, we got to bring out the classic wave equation. Speed equals frequency times wavelength, or V equals F lambda. Now here's the absolute key. We're talking about the same sound. That means its frequency, F, doesn't change, no matter what it's traveling through. So that tells us that speed and wavelength are directly linked. And wow, look at the difference here. In air, sound is kind of plodding along at about 340 meters per second. But in water, it's a speed demon, clocking in around 1,500 meters per second. That is a huge difference in speed. So what does this all mean for our answer? Well, since the speed is so much higher in water, and we know speed and wavelength are directly proportional, the conclusion is simple. The wavelength of the sound has to be longer in water than it is in air. And that right there is a perfect answer for a compare question. All right, now for the big one. The command word that can make or break your score? Explain. This is where you have to connect the dots. You need to link different physics ideas together to show you really get the why behind what's happening. Let's take a look at a classic example you might see. The question asks you to explain, using the idea of momentum, why the gas inside a balloon creates pressure. This isn't a one-word answer. You need to build a logical chain of events. So here's how you build that perfect logical chain to get all the marks. Ready? Step 1. Those zippy little gas molecules are constantly smashing into the inside wall of the balloon. Step 2. When they hit the wall and bounce off, they change direction. A change in direction means a change in momentum. Step 3. And what do we know about the rate of change in momentum? It creates a force. And finally, step 4. That force spread out over the entire inner surface of the balloon is what we call pressure. See? Each point flows right into the next. It's a story. And behind that beautiful explanation, you've got these core physics formulas. This is the why behind the why. The change in momentum, the force, and finally the pressure. Tying your words back to these ideas shows you have a really deep understanding. You know that step-by-step logic we just used? We're going to need that same mindset when we switch over to the calculation questions. Because here, it's not just about getting the right number at the end. How you show your work is absolutely everything. Okay, listen up because this is probably the easiest mark you'll ever get on this paper. If a calculation is worth 3 marks or more, you get a mark just for writing down the correct formula before you even touch your calculator. It's a free point. Never, ever forget to do it. Now, here's a very specific trick for those questions that ask you to show that a value is, say, 79 kilograms. You can't just do the math and write 79. You have to prove it. And the way you do that is by showing what's called an intermediate answer. So you punch the numbers into your calculator and it spits out something like this, 79.056 kilograms. You've got to write that number down first. This is your proof. It shows the examiner you actually did the calculation correctly and didn't just work backward from the answer they gave you. It's so important. And then after you've shown that unrounded proof, you can write your final answer, rounding it to the 79 kilograms the question asked for. This two-step process, show the unrounded number, then show the rounded final answer, is the secret to getting full marks on these show that questions. Whew, okay, we've gone through a ton of strategy here, so let's pull it all together into one final, super handy checklist for you to have in your mind as you walk into that exam hall. First things first, always spot that command word before you write a single thing. Second, make sure you use those key physics terms, momentum, force, area, in your answers. Third, for calculations, always write the formula and check your units. Fourth, don't forget that intermediate answer for show questions. And last but not least, round your final answers to 2 or 3 significant figures, unless they tell you otherwise. And that's really it. This isn't magic, It's all about strategy. You've already done the hard work of learning all the physics. Now you have the tools to show the examiner exactly what you know. So walk in there with confidence. You have the strategy. Go earn every single one of those marks. You've got this. Fundoo Tutor is a personalized learning platform that helps students succeed in Cambridge, IB, and other international curriculums with expert mentorship, structured learning support, and engaging resources.